Welcome, Digital Pathology Trailblazers. Today, my guest is Dr. Richard Levenson. And let me start with the story how I met, and met in quotation marks because we actually never met in person.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
I got introduced to Richard with his work. I didn't know it was his work. I mean, I heard the author of the paper, but it was still during my residency at the veterinary conference in Fulda, Germany, where it was the first time when his paper about training pigeons was introduced. And the title of this paper is Pigeons as Trainable Observers of Pathology in Radiology Breast Cancer Images. And this was presented as like kind of a funny thing, funny research. And I didn't know it was Richard's paper, but I believe any pathologist will recognize the picture from this paper, a pigeon sitting inside a box with some grain disposing device that gives the pigeon a reward for a correct classification of the malignancy of the tumor. So that was the first thing. And the second thing was quite recently, and then we were already connected on LinkedIn, and we kind of started conversation, was another paper called AI in Pathology, What Could Possibly Go Wrong, where there is a list of what could possibly go wrong. And that's what we're going to be talking about. So Richard, welcome very much to the podcast. How are you today?
Thank you so much. I'm reasonably well. It's sunny and gorgeous here in Davis, California. For those of you who don't know, and that was probably 98% of you, is just 12 miles away from Sacramento, where the UC Davis Medical Center is.
Fantastic. I didn't know it. I mean, I knew you were in California, UC Davis, but I didn't know exactly where. So, Richard, let's start with you. I would love you to introduce yourself to the listeners and talk about yourself, talk about your research, talk about the focus of your research, and then we're going to dive into the episode.
Thank you so much. It's a real pleasure to be here or in Davis. My particular story is very, very unusual. And in fact, I was asked to give a talk on it, or talk about me to, I think it was at Dartmouth. And the title of my talk was My Path in and Out of Path, because I've literally been in and out of pathology over my many years. And I actually started as an undergraduate studying early modern English, French, and German history and literature.
Okay.
Yes.
Interesting. That explains parts of one of the papers.
That's entirely possible. And the title that I should have had for my thesis, but I didn't have the courage back then, was it was about the French Restoration, and the title should have been Charles X, Bourbon on the Rocks. But I didn't
dare to do it.
With deep regrets. So managed to extract myself from history and literature and went to medical school. And then
did you actually practice the literature? Did you?
Well, I actually did a post MA BA time at University of Cambridge or Cambridge University. To this day, I don't know whether it's University of Cambridge or Cambridge University, but one of the two. And I was doing more history and literature there. Interestingly enough, with the same tutor that my mother had when she was at Cambridge. What? Yes, okay. Bizarre. But fortunately for me, I had spent the summer before that in a wonderful thing, Judah Folkman's laboratory. Judah Folkman, for many of you will recognize as the sort of founder of modern angiogenesis research. In other words, how tumors get their blood.
How, as a literature researcher, did you spend the summer in an angiogenesis lab?
I have one word for you. Nepotism.
Okay.
Literally,
connections is everything.
My nepotism literally means sort of doing your nephew a favor. And it turns out that my uncle had been a neighbor of Judah Folkman's. And so this was literal classic nepotism. And I had, to be fair, I had done enough of sort of pre-med courses to qualify to go to medical school. So I wasn't completely naive. I knew what organic chemistry was, et cetera, et cetera. And so I got put into Judah Folkman's lab that summer. And it was such a fantastic experience that history sort of paled in comparison. I lasted one term at Cambridge and only managed to learn and then forget how to do the London Times crossword puzzle. Then I came home and rejoined the lab and then went to medical school the next year, University of Michigan.
Interesting.
There, the other sort of fortunate thing was that in my years, all smart kids went into internal medicine. That was sort of the track, The not so smart ones went into orthopedic surgery, and the smart ones all went into internal medicine. So I was tracking myself there, but with no real internal sense of destination. And fortunately, one of my friends said, "Have you considered pathology?" And I hadn't. In fact, to the extent that I had actually failed the final in pathology. I passed the course because of the quizzes, but I failed. 69 is fail. Here I got a 69 on the final. And but he said, you should go into pathology and he knew I was interested in research, because it means that you can, study anything you want. If you go into derm, you have to do skin for the rest of your life. In pathology, you could study anything. And secondly, if you go to a good academic center, you can be on the autopsy service, which is like only a 20% commitment. And the rest of the time you can have for
yourself.
Lab. And then also, you don't have nights and weekends if you're on the autopsy service, because they just put the body in the chiller over the weekend. And it sounded great to me. And that's exactly what I did. I went after Michigan Medical School. I went to Duke University to be on faculty. Along the way, I also managed to help one of my friends who was also one of these smart kids who were going into internal medicine, but because she was smart. But she was so committed to that she was in horrible despair and was crying every night. And I said to her, have you considered pathology? And she had not. And she looked into it and she loved it, and she became a career.
But why is that? But actually, I have a similar experience. I didn't even know when I was studying in Poland, studying veterinary medicine, I didn't even know that pathology that as a veterinarian, you could be a full-time pathologist.
Yeah.
I liked it. I was lucky enough to have a board-certified pathologist teach me pathology, because I did it in Spain during my exchange year. And we had a private class for those exchange students, because they were transitioning the curriculum and they didn't really know where to put us. So we had 9 people pathology class with a board-certified pathologist. And I'm like, wow, this is so cool. But after I went back to Poland to finish vet school, I had no idea I could do this full time, because in Poland, at that time, you had 4 veterinary schools, and the only veterinary pathologists were working in those schools. So maybe you had 20 veterinary pathologists, and we still don't have any accredited residency centers. So yeah, people don't know how cool pathology is, and how life compatible it is.
Yeah, exactly. And let me just finish the story about my friend, and then I'll give a little bit about the state of pathology training for medical students. So anyway, my friend switched out of internal medicine destination to pathology, and she later that year a few years later, she told me that I had saved her life. So she was the only person whose life I saved in medical school. I was a fellow student.
As a pathologist. But you know what? The physician burnout is a real thing. So yeah, it's a real life-saving something.
I'm of a certain era. We had a whole pathology course as medical students, like a whole semester, every several times a week, and pathology lab and everything. And nowadays,
are you telling me that it's not the case?
Not the case anymore. You get histology, but pathology just shows up as sort of an afterthought for case presentations.
What?
You get a presentation of heart attack.
I'm sorry, I'm in shock and hyperventilating. In American med schools, you don't have a pathology course?
Well, I don't know, and I can't generalize, but it certainly changed dramatically. And the pathologists show up as sort of part of team teaching, where you get the clinician, and then you get the surgeon, and then you get the pathologist who says, oh, it's really X. And they just show up as sort of the answer giver rather than,
oh my goodness.
Very sad. And
this
is sad. Pathology is dropping.
I hope I get a bunch of comments. This is not the case in the US. And in our school, we have pathology as a course. I hope I get this.
Please do. This is just my impression. But I think it's sort of generic. There's so much demand for time, teaching time, so many things the school has to get through that pathology has taken
but that explains why people just don't know what pathology is if they don't have a course.
That's right. Okay. So that's why we need AI in pathology, because there aren't any pathologists.
Maybe then it's going to be also cooler, because it's going to be AI powered, and then more people would be interested in it. But why path in and out of pathology?
Actually, I was at Duke for 9 years, assistant professor. I had my own lab, and I started to get into technology back in the day. confocal microscopy was a wild and crazy thing, and started to do confocal microscopy for pathology. And my other lab was trying to understand the function of plasminogen activator inhibitor type 1 in cancer. And I kept getting very conflicting results, so much so that my research just never gelled. And sometimes I would find it in the cytoplasm, and sometimes I would find it in the nucleus. And I thought this was just artifacts. And essentially my research cratered. And so my career at Duke cratered. And come to find out, sort of 10 years, 15 years later, that Pi1 is a really complicated and interesting molecule. And my results were actually accurate, and it can be intranuclear as well as cytoplasmic. And I just didn't have the courage to go after these anomalies as if they were true and or potentially true and not just artifact.
Your research was kind of inconclusive, but then it turned out that it was inconclusive for a reason.
Yeah, I mean, that's just sort of a moral, which I think has been, the people who really are successful are those who embrace results that make no sense and pursue them rather than throw them out. And they're the ones who break the paradigms, right? And I didn't have the courage to do that. So, in fact, my career is what got broken. And it's just another story of sort of how I got out of pathology. So my research career was done. Although I was board certified, I really had no clinical skills left. And it occurred to me that, I really needed to go back and just be a practicing pathologist. And the person who sort of told me I was no longer have a job at Duke said, but we're going to give you, a year's salary and you can do whatever you want. And I said, maybe I just need to go back and be a resident again. And I think I've done something that no one in the history of the world has done. I went from being an assistant professor to being a first-year resident in the same department.
That is definitely non-standard career step.
Exactly.
Oh my goodness.
And I lasted about 6 months there, not because it was so terrible, but a friend of mine said, oh, you should really look at this. And she showed me an an advertisement in Science from Applied Spectral Imaging, which showed the use of spectral imaging to understand histology examples. So in other words, instead of just looking at sort of color images of red, green, and blue of HA, if you use a device which they had developed, which was a spectroscopic camera, you could get a color spectra from the H&A stain slides and actually distinguish things that you can't distinguish by eye. I thought that was really cool. And I had this sort of confocal microscopy experience, and I called up the company and said, hey, you want a pathologist to help? And after some hemming and hawing, they said, sure. And I actually got a job with the company, but at Carnegie Mellon University.
Okay.
Which is
my goodness.
Strange. And which doesn't have a medical school, but was right next door to the University of Pittsburgh. And I started developing applied spectral imaging tools for multispectral imaging and pathology. And that went well for about 3 years. And then things changed, as they do. And then I took a job in industry, in full-time, full-bore industry, Cambridge Research and Instrumentation, to develop a different technology of multispectral imaging, which has turned out to have real legs because, as your audience knows about omics, pathomics, or multi-omic stuff, one of the technologies that's used for that is to do fluorescent imaging and use a spectroscopic tools to actually distinguish more than 4 or 5 or 6 different probes. So the company that I worked for, eventually their technology ended up with another company called Akoya Biosciences.
Which is very familiar to my
That's right. So it's still,
listeners.
that's really, I'm happy because most people who develop, work on technologies from 15, 20 years ago don't usually see it come to fruition, but the same thing is still cooking and is out in the market and making real science. So I'm fortunate to have that sort of part of the background. So I actually worked for a company. So this is my path out of path, like 10 years. I became vice president for research, if I recall correctly, in this technology company, which again is unusual for a history and literature major.
Indeed.
And that ended, sadly. All my sort of interesting joints or adventures have a non-classic ending. And one day I was asked to leave because of various reasons. And but here's the thing: as I was driving home,
did you do something?
No, it was I was looking for potentially another job, and mistakenly pressed the reply all on my email.
Okay.
You know, stuff happens.
I already love this episode. We're like still in the introduction part. I love it. I love
Yeah,
it.
I'm just saying that, there's a lot more than classic, career paths out there.
This is
But
so
here's the
cool.
point. I was driving home from being, asked to leave, and my car was headed direct into not just one, but a double rainbow. So that was a sign from the heavens that there was.
It was that you're supposed to leave.
Exactly. And then I did something that you don't know because it was sort of sudden. I did what everyone who's suddenly deprived of a regular job. I became a consultant,
Yes, yes.
and I
How
was
did
really
that
lucky.
develop?
That went actually very, very well. My income actually didn't go down, and my first major job was, this is where I get into digital path with Omnix, if you recall, which is the joint venture of GE and University of Pittsburgh, if I remember correctly.
Get some approval at some point, like
Well,
a
the company
clearance for
basically
something.
cratered as a company, but I think their IP sort of lived on and may have been absorbed by somebody else. Anyway, I was working for a year and a half there as a consultant on the sort of the first, serious digital pathology company.
Which year was that?
Oh, a while ago, probably
90s or
19. I can't even tell you.
I have this digital pathology timeline, which is
Yep.
like pre 2000, pre whole slide scanner and post whole slide scanner. And then they're like sub parts of this timeline, like pre FDA clearance of the Philips and post.
Actually, when I was with Applied Spectral Imaging, I worked with Dirk Sankson, who was the founder of Apereo.
Oh my goodness.
Yeah, so these are all these chance encounters with major players, which has been very, very interesting. So about 2009 is when I left CRI, and probably around then is when I started working for Omnix. And then that my consulting gig lasted for 3 years. And here's the last thing that never ever happens. I'm just sitting at home working from one of our bedrooms in Brighton, Massachusetts, and I got a phone call, and the person on the other end of the call said, "Hi, Richard." She's from Romania, I think. "Hi, Richard. Would you like to be a professor at UC Davis?" And I said,
person from Romania calling.
No, I mean, she's a faculty member at.
Okay.
Yeah, no, that would be very, very strange. But I was just I was putting on a Slate accent. It's from a European accent. No known specificity.
So like she took you out of consultancy with a phone call to become a professor at UC Davis.
Right, full professor with tenure.
Like without
I didn't apply. They just said, "Hey, you want to be a professor?" And I said, "Sure."
You know what? Everything can happen.
So I've been here at UC Davis for coming on something like 12 years. And it's been really a wonderful run.
So you didn't get bored at UC Davis. You didn't get kicked out.
Yeah.
Right. So yeah, tell me about your research at the UC Davis.
Well, sure. Well, I mean, it was at UC Davis that I managed to do the pigeon work.
Yeah, I want to hear about, like, how did you come up with training pigeons?
It was easy. I'm driving to work, and there's somebody on the radio who's describing a UC Davis researcher who was talking about his work on pigeons and visual recall.
Pattern record.
Yeah, visual recall. Can they recognize, sort of how
you heard this on the radio?
Yeah, I heard it on the radio, and I thought, wait a second, visual recall, that's what pathologists do. And so I called up this guy and said, "Hey, do you think it would be a good idea to look at
borrow a few pigeons?
Whether pigeons can do what pathologists do?" And he said, "That's a great idea, but don't talk to me. You have to talk to Ed Wasserman, who's the guy in Iowa who actually is the major player in this field and all the pigeons." And he thought it was a great idea, and then we just did the research.
So, who you built this cage for the pigeons?
No, that's his stuff. So he
already has for training pigeons for
all kinds of
researching.
Very sophisticated investigations. And in fact, he recently published a paper showing that pigeons and humans look at images the same way. In other words, what the components that are important to humans are important to pigeons, which makes sense because Pigeons are very visual creatures.
Mhm.
If you think about the world they live entirely visually. They don't do things by touch. They don't do it by hearing. They don't do it by smell. They're out in the, so they have two tasks. One is to, sort of find their foodstuffs, and the other is to avoid being eaten by camouflaged snakes. Okay?
Okay.
Camouflaged snakes.
What do we
That's a
mean by
huge,
that?
I mean, literally, a snake can have colorations. I have an image somewhere that look just like, for example, fallen leaves on the bottom of a forest floor. On
But
a
we're
forest floor.
talking literally about snakes? I thought
Yes,
that
yes.
like
Not, I mean, no.
falcons or birds of prey
Well,
would
no, but I mean, a
hunt
pigeon
pigeons.
is wandering around on the ground,
Oh, okay.
and snakes like to eat birds, and they have to make sure that they don't wander into a snake. And
I have never thought snakes are a threat for pigeons. Maybe because I come from Poland and we only have like 2 species of snakes.
maybe so. But yeah,
Maybe.
I mean, I actually, I'm not making this up. I looked up sort of, potential predators for pigeons in the world. And the point is that snakes have, their job is to catch prey, and they are extremely sophisticated in their camouflage. And if you look at a camouflaged pigeon among, a camouflaged snake among, leaves on a forest floor, it's pretty much the same problem as telling the difference between, sort of normal and cancer epithelial cells.
Malignant
They're,
epithelial cells.
they look very, very similar, or can be. So certainly to an unsophisticated person, you can't tell them apart. And so pigeons have the skills to tell, tiny, tiny pattern differences apart. And that's what pathologists do.
Oh my goodness, this is hilarious. This is so cool. So you did pigeons at UC Davis.
Yeah.
What about?
I didn't know what to do. One of the huge frightening things for me was to come to a place and they say, here's your office, here's your lab, here's your startup package. Good luck, Dr. Levenson.
Mhm.
What do you do? Since I had no clinical responsibilities, everything had to be research. And I really didn't know what to do. The pigeons weren't a serious thing. They were just a hugely fun experiment that went viral. But that's not something you can make a career out of. But I knew I was
went viral. Yeah, like if there is any research paper in the pathology world that went viral, this is the one. And I was just presenting at the conference at the ACP, American College of Veterinary Pathologists annual meeting. And I had slides where I had like snippets out of literature. And then I had this like contrast literature versus real life. And my real life example was the number of followers that clinical pathologists using static pathology and veterinary medicine have. And like, one account had 29,000 followers, the other one 17,000, the other one, I don't know, 15,000. And I think that this is more than all those other publications that I showed before, and I showed like 10 publications ever had. Like, I don't think people read this stuff, but the pigeon thing, everybody in pathology world, they know about this.
Just lucky, I guess. There was a paper last year called, the title of the paper was "Pathologists Are Not Pigeons."
See, like,
yeah,
there's a whole subculture of this.
I know, exactly.
I need to make a video on TikTok about it.
And, I was told, just again, a little bit of sort of career story. I mean, people said, you're wasting your time. This is not going to help you. This is not serious. So don't listen to people. Do what you want. Do what's fun.
I totally signed this this
now
sentence of wisdom.
However, I do have to say that's said from a perspective of late in life, full professor with tenure, right?
Different the position out of the blue.
So I even wrote a poem that says, I'm professor, I'm vice chair, I've got tenure, and I don't care. And that's I have to admit, it's a very privileged situation to be in. So, but fortunately, I did manage to connect up with an old friend of mine who developed some interesting technology using ultraviolet illumination for imaging. What he was doing was in vivo imaging, and the trick there was UV at not just what sort of pathologists think of as UV, which is like 350, 380, basically just below blue. This is sort of semi deep UV at 260 or 280 nanometers, which is so UV-ish that it doesn't even go through glass. So you can't use a standard microscope lens. You have to use quartz. But what it does is it did an amazing thing. Because you may know, light traverses tissue, the depth in which it goes is very, very dependent on the wavelength. So, red goes all the way through. You can see a red laser pointer through your finger. You put it in one side and then you look at the other side and it glows.
Yeah.
And if you go a green or blue laser, you don't see anything because it all gets absorbed right away. And ultraviolet is even more so. It gets absorbed within 10 or 20 microns. So you don't need, and here's the trick. That means you don't need to make a thin section slide to get thin sectioned histology, because this UV light goes in 10 microns, which is sort of like a thick slide. And then what's really cool about when it goes in is that it excites autofluorescence. And interesting enough, unlike sort of the fluorescence that we're used to when you look at a fluorescein or a Psi3 or a Alexa this or that, where the excitation, let's say, is at 680 and the emission is at 710, they're within 10 or 20 nanometers of each other. The excitation at 280 actually generates fluorescence way out in the visible. So you can excite at 280 and you can still get red, green, or blue light coming back out, which means you can collect the light with a standard microscope lens and go and collect it with a color camera. So it is amazingly simple technology to do what the field calls slide-free pathology. You don't have to make a slide and you get histology. And lots of people are doing this, many, many different approaches. Some of them are extremely compelling. However, often they use lasers, they use computers, they use optical shaping devices to make structured illumination. They use sound waves, all kinds of crazy things. And this just uses an LED, a UV LED, a regular microscope lens, and a color camera. So it just, and in fact, it's been implemented by a junior colleague of mine on a cell phone.
I'm like staring into this camera. I'm like, yes, I want to talk about it, because when I was researching you, I'm like, okay, let's talk about this main thing, AI, but there's so many different things that you did. And I'm like, we need to talk about this as well, because it is something that everybody thinks is like very for future, this glassless pathology. When is it going to be? And oh my goodness, and now you're saying it's on the cell phone. Tell me about it. I want to talk about it.
So we spun out a company from our lab. And by our, I just want to give full credit to my colleague Farzad Feradouni, who started as a postdoc in my lab and is now just coming up to be associate professor, which is a nice evolution for him. And so he basically sort of built all of these systems that I can talk about. And so a company.
What's the company name?
Well, it's now it also went through a few changes, but I think it's now called Smart Health Diagnostics.
DX?
Smart Health DX. Have you heard of them?
Yes, I have. Recently.
Okay. So they took over this technology and they're moving ahead with it. But in the meantime, my colleague Farzad came up with a different approach, which doesn't use UV at all. It uses just blue light, but it generates images immediately that look just like H&E, a thin section. And that, it's a terrible name, but I called it FIBI, fluorescence imitating bright field imaging. So it's a not very sophisticated name, FIBI, but I actually did it as a kind of rhyme because I had previously had a brief exposure to another kind of multiplexed imaging using lanthanide labeled antibodies.
I don't know what that is.
Well,
I know what antibodies are, but I don't know what's lanthanide.
There are two groups that are doing that, both companies, and you can look at between 40 or even 100 different antibodies simultaneously, because the signals can be separated using mass spec. And so I worked on that and actually gave that one of those technologies a name, which was multiplexed ion beam imaging, which is MIBI. So then I did FIBI.
I know MIBI.
You know,
I know MIBI. Yes, I know MIBI. I didn't know what it stood for. I know MIBI.
So I named MIBI. And actually, the other thing I like about MIBI is that I get to say how it works. It's you scan the tissue with an oxygen duoplasmatron. That's the device that makes oxygen ions that are strong enough to blow up these lanthanides and send them off into the mass spec. This gives me the chance to say oxygen duoplasmatron. But I don't do that anymore. But anyway, MIBI became FIBI. And we founded another company called Histolix. And we're trying to get that up and running. Actually, a paper was published earlier this year, a validation study. We looked at 100 different cases and compared the FIBI images with standard H&E and got a 97% concordance with pathologists who've never been trained on FIBI. So the images are
Evaluation.
to be just read directly by untrained or unprimed pathologists.
FIBI, the blue light thing.
FIBI, FIBI.
Okay. And what was the previous one? The
Well, that's called
ultraviolet?
MUSE.
MUSE.
MUSE. What is it? Microscopy with UV surface excitation.
Exactly.
And I call it MUSE in honor of the co-inventor who was Stavros Dimos, who was from Greece. So MUSE in Greece.
Because the MUSE is in Greece
Yeah,
mythology.
so
okay, I see this like words are important and language is important. There is a theme there.
Exactly.
Okay, so MUSE is now acquired by
Smart
Health DX.
Mm-hmm.
And then FIBI, you're starting with FIBI. You just finished a validation study.
Right.
Okay. Is MUSE being used for any like diagnostics at the moment?
I don't know if it's being used, but it is certainly being, I think, geared up to go through the FDA and get out there.
And I know that the company is going to be advertising on to veterinary professionals and veterinarians as well.
Yes, they have a couple of things going, and of course we do with FIBI because UC Davis is home to the world's #1 vet school, if I'm not mistaken.
Yes.
And so we've got some collaborations going with veterinarians and vet paths people. So
interesting.
And there's some technical advantages to FIBI. For one thing, the images look like H&E directly, strangely enough.
How do you make them like H&E? What do you?
They just are that way. So how does FIBI?
Like you just, but how they are that way?
Okay.
Do you stain it with something?
No, I'm sorry. The thick specimens, which can be fresh or fixed or frozen, but just not. They don't have to go into paraffin. They don't have to be thin cut. So you can just take a piece of tissue right out of the.
It's a surface, like surface image.
Surface, right? And then we stain for 20 seconds with hematoxin and 20 seconds with eosin. And
that sounds familiar. It's H&E.
That
image is differently.
That's right. And then the magic is it's bizarre. And we excite with 405 nanometer blue light from an LED. Okay. So you think.
A step back. How do you make MUSE images to look like H&E?
They're fluorescent. So and the
you
colors
have to translate into.
For you, it's easy. You can invert them. You can.
So you basically like translate the colors into different colors.
Exactly. So you
map the colors into different colors.
Right.
Whereas your colors.
They can look very, very H&E like. And a lot of the other techniques, generate 2 grayscale images, and they just take one image and make it blue, and the other image and make it pink, and squish them together, and it looks like H&E. The advantage to MUSE and to FIBI over some of the other techniques, or an advantage, is that it uses a color camera, which means that you get lots of colors, not just a blue channel and a red channel. And as you know, pathology has there's more to life than red and blue.
There is green, for example.
This reveals things about the tissue you don't see of other things.
Amazing. So, okay, FIBI is H&E without glass,
right?
With a normal microscope camera with a microscope lens.
Yeah.
And what about
a blue light excitation?
And
so why does it look like bright field?
Yeah, why?
Because the excitation light, the 405 nanometer excitation light, goes into the tissue, past the surface, and down into the bulk tissue. Because don't forget, these are thick slices. By thick, I mean 100 microns and on up, a tenth of a millimeter. So not thick in any real sense, but thick certainly in terms versus a thin slide. But we typically look at 1 or 2 millimeter, 3 millimeter sections that you can easily generate just with a razor blade. What happens is the blue light goes into the tissue and creates tissue autofluorescence, which just becomes this sort of cloud of whitish light in the tissue, half of which comes back through the surface, through the lens, into the camera. And when it goes through the surface, it gets absorbed by the hematoxin and eosin stains, which is exactly what happens on your regular microscope, right?
But from the other side.
No, I mean...
Like this one goes from the inside and illuminates, and it's the
same idea. I mean, basically your microscope light is from below the surface. And FIBI, the autofluorescence is generated below the surface. And then it comes back up.
Okay, yeah, it's like a microscope light underneath the surface that you're trying to image.
Exactly.
Oh my goodness. So, Richard, where, like, is this now, are we going to get rid of glass within the next year? Like, where do you see it coming? And what are the disadvantages of this? Like, why is it not yet everywhere?
Well, I
Maybe
blame
because you
myself.
patent it and you don't want to
Yeah,
give
yeah, I know.
anyone.
It's first of all, MUSE came to life in a happier investment time. As you
Okay.
know, some investments these days are much harder to come by. People don't
Mhm.
just throw tens of millions of dollars at you the way they used to. So it's been a little
That's
bit
too
harder
bad.
in the fundraising world.
Uh-huh.
And secondly, I think it's a matter of getting the work done, getting the word out, and then demonstrating it as not just as pretty pictures, but actually functionally useful. And the
Okay.
utility of this kind of work, and we will get to AI in a second,
Mhm.
is that you can speed things up. So intraoperative, you can get rid of frozens.
This is like basically you're taking pathology to where radiology is, where you don't need the analog part of it.
Exactly. And so it goes right to digital, direct to digital from the tissue. No slide, no film, right? Same thing.
You basically radiologize pathology with this.
Right. And in fact, we can interact with radiology because a lot of interventional radiology sort of culminates in a needle biopsy, and then they don't know what's in the biopsy, right? So we
And
can
then you
then
just FIBI it and you see
exactly
what's in the
right then and
biopsy.
there, and you know if you hit the tumor, whether you have adequate tumor for your molecular, and maybe even do a definitive diagnosis just on all at once.
Oh my goodness, people who are watching this on YouTube are going to see me like with very wide eyes.
Yes.
This is amazing. So how much more time do you think till it hits the market?
If only,
Like in the best case scenario and in the worst case scenario,
well,
but
the worst
a
case
positive
scenario
scenario.
is that something will certainly hit the market. I mean, slide-free
Mhm.
microscopy, there are 5 or 6 or 7 people with different technologies all
Mhm.
vying to do this. It will happen.
Mhm.
Who's going to win? It's really an
We'll see.
execution story.
Mhm.
VHS beat Apple Betamax, right? Or it was better execution, poorer technology, but they won. So we'll see. But I would say within 3 years, it will be in frozen section rooms, which is pretty.
Okay.
And
Well,
before that, it'll
exciting.
be in researchers' hands. And depending on what the FDA does, it could be a LDT, right? If you just validate it
Mhm.
in-house, we don't
Mhm.
have to wait for the whole FDA approval story. You validate it in-house, and then you can use it internally. And then veterinary, you bring in a racehorse from 50 miles away. That's not easy. And then you do a biopsy, and then you send the horse away, and they have to come back a week later
For
because
another biopsy.
so now you can do it all with the horses there.
Amazing. Oh my goodness. Ha. And you also touch on something that is like not so obvious because a person can come back for whatever procedure immediately. They usually go to, well, they travel as well, but horses are difficult to transport.
Yes.
Amazing.
And what's really, really cool is the NIH seems to like what we're doing, and we've received
That's a good sign.
a bunch of major grants recently. One just worked through all of the paperwork. This has been funded to develop FIBI for core needle biopsy of breast cancer and develop and test in the country of Ghana in Africa.
Oh my goodness.
5-year award.
Why Ghana out of all the countries in the world?
A good question. Well, I had reached out to a colleague of mine at ASCP, Dan Milner. I don't know if you've come across him.
No, no.
And he's been very active in global health stuff. And I said, I've got this really cool technology. Where should we go? And he said, I have this great person in Ghana, Beatrice.
Connections is everything.
So just lucky. She's the CEO and she's a breast cancer surgeon and founder and CEO of a hospital in Ghana, and a very prominent person with lots of, all of the right tools
Influence and
this work.
Mhm.
And then
I want to also know the part with the smartphone.
well, that hasn't been pursued. It was so my colleague Yi Liu at Cleveland Case Western Reserve basically just figured out how to hook up a little LED. This was a UV LED and on an Apple phone, and a nice microscope lens, which is basically the same lens that's in the phone. You just flip it, invert it, and it becomes a microscopy system. And he was able to power and then use of course, the camera in the phone, and he was able to power everything with the iPhone battery. So there were no cables at all. And you could do really wonderful histology just by touching the phone to the surface of the tissue. And it was published.
I need to find this publication.
I think I'm on it somewhere. So if you look up me and MUSE.
I'm going to Google Scholar U and
yeah.
find it.
But the images are gorgeous, and it's from a cell phone and the extra costs to turn a cell phone into a microscope was like under $100.
Wow. It's just like rebuilding the smartphone or having like an attachment.
It's just a little, actually very thin. I mean, he did a great job. It's just a machine, a plastic machine part that just fits over where the camera and the lens are right now. It's about, I don't know, 2 or 3 millimeters thick, and it's freestanding. In other words, it plugs into the phone somehow, but it doesn't need any other wires.
And is it being used anywhere?
I don't think so. It's being used. I mean, it's. I have no idea why it's not being used.
Okay,
but
I will investigate that topic.
I mean, it absolutely should be. And the same thing we can do with FIBI. We haven't done it. It would be a gorgeous grant. It would be wonderful for school kids, right? Imagine having this and being able to do microscopy in the 5th grade. Imagine how that would open up people's eyes.
Yeah, but also like everywhere.
Everywhere, exactly. You're out in the forest. I mean, you can do it anywhere.
Amazing. Maybe. Can I buy it?
We can take this offline and we can see if it can be revived. But somebody needs.
Yeah, I'm gonna find the paper. Check this out.
Okay.
But okay, so glassless pathology, pathology that actually is now on par with radiology regarding the technology. We basically have the potential to very soon eliminate the complaint, oh, it's analog, and then you have to add digital pathology and AI on top of it, and it's overhead and it's everything, because we still do analog. Now there is potential not to do analog.
It's direct to digital.
Direct to digital. So exactly like radiology. So this is where your encounter with AI happened? Or tell me your story with AI and your relationship with AI and pathology.
My career is very, very strange. I've had one graduate student in my entire life.
As a full professor.
Well, I mean, don't forget, I was sort of 13 years in industry, right? Or 15 years in industry. I was just an autopsy pathologist way back when, so I didn't really have any standing to have a graduate student, but I joined the biomedical engineering graduate group when I was at Davis, and a student reached out to me to join my lab and do his PhD with me, which is remarkable. And he actually did it. It was 4 years through the COVID thing. I never saw him. He did all his work from home, and he was doing AI.
PhD from home. I love it.
That's right. And he got his PhD just now. He's nationally or internationally famous. Why? He got his PhD at the age of 19.
I think I saw a news press release or something about it. How? Tell me how. So 19, he started at 15. You're not even done with high school at 15.
I know.
Tell me the story.
He's way outclassed his sister, who is doing not a PhD, but right now just a master's degree, and she's already 17.
Oh no, that's like failure. Oh
in
my
voice.
Goodness. This is like mind blowing, right?
So at 17, she's an absolutely professional level singer. And in fact, during the graduation ceremonies for all of the graduate students at which my student received his PhD, she was the one who sang the national anthem for this whole.
Oh my goodness. This is like some movie story.
Exactly. We're still working together. We just had a paper accepted in Optica.
Okay. There is many good collaborations between the optics and like the light vision scientists and pathology is the super cool intersection. Actually, the first company I worked for, where I encountered digital pathology, one of the founders had the Nobel Prize I would have to Google what exactly but it was something with microscopes and optics. Let me Google him.
So he and I were working with another imaging technology. This is stain-free imaging.
Stain-free, so not only glass-free, now it's stain-free.
This is glass-free and stain-free and super high resolution, but it's grayscale. So I didn't say what my graduate student did. He was working on AI tools to convert one image into another image type. And so he was taking the MUSE images and the FIBI images and making them look identical to H&E. And then we did the same thing for this other technology, which is called, it's another phrase I love, QOBM, quantitative oblique back illumination microscopy,
Mm-hmm.
which sounds frightening, but it
It
fits
does.
in my
It sounds
general.
like this other word that you like to use,
Oh,
the
yeah,
oxygen
oxygen
something.
dual plasmatron. But the oxygen
Mm-hmm.
dual plasmatron thing, that's a $500,000 million box. This
Uh-huh.
is another one that fits into my theme of appropriate technology. It also requires just a couple of LEDs, a microscope, lens, and a camera. That's all. And it does
Okay.
high resolution, super fast imaging of unstained tissue. And this is not only just the surface, but also a little bit depth resolve, really fast, really cheap. And then what my graduate student and I did with this other group, I didn't develop the technology at all, but we developed the AI tools to convert these grayscale images into things that look just like H&A. And so that was what was published.
So what are you going to do with all those different microscopy technologies? Is there going to be one that's going to win it?
No, I think they're all good for different things. So this QOBM thing, I don't like FIBI for in vivo because it involves a stain. This is stain-free. It could be hand-filled. And one of the first potential uses is, for example, looking at brain tumor, intraoperative brain margins. And so that's what part of the paper was. We showed that you could tell the difference between non-normal brain using QOBM and convert it to H&E.
So this was your first encounter with AI?
No,
or like
actually,
hands-on encounter.
I go way back.
Tell me about your history and your relationship with AI and pathology. I want to know about.
Well, back to this company that I work for, Cambridge Research and Instrumentation. We developed this multispectral imaging, and then one of the people who I'm still pals with developed neural net tools for segmenting pathology images. So it wasn't deep convolutional neural nets, but it was like a 3-layer neural net. And this is back in the mid 2000s, right? And it developed into a software called Inform, which remarkably,
yes, that's Akoya.
It's at Akoya. It's still being sold.
It's being used for IF.
So this is way back when, and actually I have a couple of patents related to that, none of which got me any money. All of it went to the company, unfortunately. But so I think I'm one of the pioneers in AI tools for pathology. Amazingly enough, just happened to be at the right place at the right time.
Fantastic. Okay, so that was which year?
I don't know, mid 2000s. And actually, I really like it. It's very low overhead, very fast. It's trained by example, much faster than convolutional neural nets, at least to sort of work through. Needs less training.
If it only has like 3 layers, that's a lot less than the CNN.
It's not necessarily as robust, but if you have a simple problem, or like given a single image and you just want to find all the nuclei in that image, you don't need hundreds and hundreds of examples because it's a very defined problem set.
I managed to find what Gerbinin got his Nobel Prize in. It was 1986, and it was the scanning tunneling microscope. Tunneling microscope. And he shared it with Ernst Ruska, because Ernst won the other half of the prize. So Gert actually won half of the prize. I didn't know you could win half of a Nobel Prize.
Well, I think you can have a group, but I think you can only split it among 3.
Amazing. Okay, so now let's go to the paper, AI and Pathology. What can possibly go wrong? And I'm going to start sharing this here again because there are some visuals in the papers that we want to address. But it was recent. This was published in 2023, which is this year, right?
Which is recent.
Very recent. But yeah, tell me, why did you decide to write this
actually,
paper?
Kei Nakagawa and I have been talking about writing a paper like this for years, 5 years now. And it kept saying, blame it all on him because I really get a chance to blame somebody else. He said, I'm busy, but
he's also the first author of the paper, and you're
exactly.
the last.
So I'll get to it this week, and then of course this week went by, and then this month went by, and then it just never happened. But we'd have like a page or two written, 5 years ago. I honestly don't know how this happened, but I think he and I talked again about sort of resurrecting it in the modern era where it would suddenly resonate with a lot of people. And
oh my goodness. Now it's like the topic of every AI discussion, like with large language models. I don't know if you guys addressed already large language models here. Yes, of course, because you generated a poem with a large language.
Yes. In fact, the first two paragraphs of the paper were written by ChatGPT, and the final poem was written by
Do you want to
ChatGPT.
read the poem, Richard? Do you want to read the poem?
We can do that. And again, I want to claim, I think, priority. And I don't know how many pathology journal articles have poems in them.
I have not read any other one with poems.
I know. So I think I'm pioneering a whole other genre. I think we should have, limericks and things.
I don't know how many enthusiasts you will find for that. Maybe all those with similar background to yours, with the English literature background.
Well, shall I read the poem that's on the screen?
Yeah, go ahead and read the poem.
Okay. So I asked ChatGPT, basically, I just gave it the title of the paper and said, please write a poem in the style of Edgar Allan Poe for whatever reason.
What reason? Why did you choose this? Is very
random thing. I couldn't think of I don't like Emily Dickinson as much as other people do, but okay. So I just said that. And it really came up with this right away. It wasn't as if it generated 400 and I had to pick the best. This was the one it came up with, and we'll go with this. And that's the amazing power.
And which chat did you use? The 3.5 or the 4?
I don't remember all of the details. And there were some issues about setting some settings to. I forget. I mean, I have it written down, but that's basically you
probably
can
it's in the materials and methods of this paper. It
so
should be because now you're required to say like what you did with ChatGPT and how much and which model and everything.
Yeah, no, all that stuff. I forget. There were some knobs you could tweak, and I forget everything about how they were tweaked. But it was very straightforward. I'm not an expert in large language models. I just was a user. But anyway, so this was a whole paper on all of the dangers of AI that might be discovered in as it gets developed for pathology, and they are substantial. And people, this is by now well discussed and to some degree well understood. So anyway, I asked the ChatGPT what it thought about this whole thing and to write a poem about it. And so this is what it says on the screen. It's up there, but I'll read it in case you're just listening to it.
Yes.
It says, the machines, they may seem infallible, but their errors, they can be terrible. A missed cancer, a false positive too, the consequences dire and askew, but yet we still march on with this quest for faster results with little rest. But let us not forget the human touch, for in the end, it is what matters much. So let's tread with caution and care as we delve deeper into this AI affair, for the stakes are high and the risks real. In the field of pathology, let us not seal our fate with machines, but with our own eyes and judgment and expertise that never dies.
Oh my goodness, this is deep. Wrote by ChatGPT.
I know.
But so no, it totally captures the spirit because these are powerful tools, and both on the imaging side and on the large language model side. And now there is a combination, like on the, popular side, there is this ChatGPT Vision where you can interact with images. You can generate image, which we're going to be talking about one generated image in this paper as well, by generative networks. But you can also have an image and have the language model extract the content of the image and describe it. And there have been attempts already to do it with pathology images. And the results weren't like crazy off, I would say.
And it's sort of an oxymoron to have ChatGPT tell us about the risks of ChatGPT, but do it in such a beautiful manner, right?
It's amazing. I mean, this has not been available. I would not have imagined it. Like, that you will have a tool that you can tell them what you want to have on the presentation, on the PowerPoint presentation. It's going to make you this slide. And this is basically, maybe not entirely, but I did it for the last conference I was presenting it. It's like mind-blowing.
It is.
But getting back to the dangers, let's talk about the image in the in the
Okay, so
paper,
let's
which
go to
actually,
let's go to the first image.
yeah, the first, yes, let's go to the first. And the second, actually, the second image, and everybody who's watching this on YouTube can look at it on YouTube. We're screen sharing it right now. And I'm going to also link to all those papers, to both of the papers in the show notes. But yeah, figure one, I'm going to read the description. Image generated by DALL-E Mini based on a prompt pathologist confronted by AI. Richard, can you tell me about this artwork?
It just did it. I mean, literally, that's what popped up, and I haven't seen a better visual representation of exactly the topic that we're discussing. There's a pathologist, clearly identifiable, and then some AI, one sort of humanoid, the other not, but with a glowing red thing in its supposed brain. And it's just a very gentle way of capturing this whole storyline, and there, it is a confrontation, but it's not,
not aggressive confrontation.
No, it's just kind of what's going to happen next, guys, sort of thing.
Mm-hmm. And it's the style of like the brains representing AI, or like brains / neural networks,
right?
Of
exactly.
representation of AI.
But I do like, just stylistically, and again, this is amazing, that sort of orange, glowing disc was just thrown in there by the artist, DALL-E Mini, and it, just dramatically improves the content of the image from a style point of view.
Interesting. So let's go to the second image. The second image actually references the Pigeon paper.
It did indeed.
Right.
Again,
let me
DALL-E
read the
Mini.
description. Image generated by DALL-E Mini based on the prompt pathologist training pigeons style of ribbons. Looks promising, except for one thing. Richard, tell us what this one thing is.
I didn't ask for it. So yeah, pathologist pigeons, perfect. I'm happy. AI is going to rule the world. But then if you look down at the bottom right, there is a strange creature that it's impossible really to describe. It looks sort of like a combination of cat and rabbit bat with who knows how many
it has
legs.
like eye-like structures on tentacles.
I know.
Has
who knows
like
what it is?
Broad
I didn't ask. But I mean, if you look at the prompt, I didn't ask for throw in something horrible. I just said pathologist training pigeons, and it put
maybe
that in.
Maybe it was supposed to be a pigeon that didn't work out. But the other pigeons are so realistic.
They're
Obviously,
great.
It's kind of well known that AI has problems with details, like the fingers always look a little bit dysmorphic. The pathologist has, I assume, these are glasses, but they're a little bit like thick, like
I mean, the things have changed.
Jar.
It's not fair. This is, a year and a half ago.
That's true.
By a sort of minor player in the field. Nowadays, the generative art is just astonishingly good.
That is true.
And it would not have that little funny thing at the bottom right. That just wouldn't be there.
And it also has these colors, like a little color scale. Is this?
I don't know about the colors, but he's wearing a nice dirty white coat.
It is because of the style of Rubens, I guess.
Yeah.
But yeah, those images represent what can go wrong, and I love what you have in this paper as well. It's a table, basically, of what all can go wrong.
One of my co-authors is one of the leading AI scientists in the world, Faisal Mahmoud, and he came up with a nice list like this.
It's a great guiding table, I would say, because you have a column with challenges, you have the column of impact of AI and mitigation strategies, which is basically what's needed, because I don't think there is a way to avoid it. And at some point, at the moment where it's mature enough and it's going to give us enough advantage in providing care, it's going to be unethical to not use it. But it doesn't mean that with the maturation of this technology, the dangers are going to disappear. And I think there is no way to have two camps. One of those who are using it and the other ones who are not using it are against it because it can make so many mistakes. It is going in the direction of, okay, what are the mitigation strategies? What risk assessment points can we have along the process? And how can we, when can we say we did the best job we could have done?
Well, Again, I hate to say this, but read the paper. There's some serious issues down the road, which has to do with the finances of these AI tools. They're very expensive to develop, and the question is, how do you lock them down and not improve them? If you improve them and spend another $10 million on a bigger data set, who pays for that? The company, and how do you charge for it, and et cetera, et cetera. So there are, just getting beyond kind of the theoretical questions of
so are you getting into the reimbursement side of healthcare?
Well, there's that, and the challenge here is that the problem is that pathologists are already doing, quote, the gold standard level of care. So how do you add costs to generate just at best gold standard of care?
Well, if you take away the glass, then you kind of took
there
away.
you are. Yes,
part,
now we're talking.
Then it kind of offsets the cost of developing everything on top of analog. But you know what? This is a question basically, how do we implement digital pathology regardless of AI? Because, and people already implement it. There are codes, there's no reimbursement yet. And I say it's better. I mean, it's better for me to do my job as a veterinary pathologist.
It's a problem. I mean, things that are objectively better still have trouble making it in the market. And you have some, and then you have downstream issues like, where do you store all these digital images? How do you pay for the storage? When do you get rid of them? It's sort of, it kind of rhymes with the problem of electric vehicles. Perfect. Tesla works
very
great.
Parallel.
Parallel. Then there's so many infrastructure issues and downstream repair issues and all kinds of things that really stand in the way. And you can't be naive about them.
That is a very good point, and I want to emphasize is you can't be naive. And pathologists as a profession, they kind of see beyond the marketing messaging of any tool. But I would want to emphasize, we cannot be naive, because obviously everybody who's gonna who's gonna be offering this, and it's the same with electric vehicles. Narrative is they're better for the environment. In which aspects are they better? What are the other aspects? And it's for any technology. It's not, it's for any technology. What I'm seeing is, okay, if there is enough noise generated that takes the narrative in a certain way, we tend to go with it. But basically, let's put it that way. It's human nature to want to trust something. And if there is enough messaging around something, then at some point you assume, okay, this is what it is. I start believing it, right? In healthcare, we cannot allow for this to happen, regardless how much messaging about anything there is. And I think we are in a kind of better position to not be naive about it, but I think we still need to pay extra attention, especially with tools that are so much better than anything else. Up to now, everything was incremental. You could compare it to what was immediately before. And now with generative AI and with the glassless imaging, it's leaps forward. And that's my point. Okay, if it's so much better, is it then ethical not to use it? But is it ethical to use it if there are dangers? So let's talk about that a little bit. And I don't think there is a good answer.
I want to talk about boring AI.
Mm-hmm. Yeah, let's talk about
boring AI. It's things like, can you count the nuclei? Can you
image analysis? Yeah, the classical applications that we had with scoring of things.
Can you do quality control on your slides? Can you prioritize your workflow? Can you order stains automatically? Can you do all of these workflow issues? And I don't think anybody, as long as the pricing was right and it helped with productivity, I don't think anyone could have a problem with that.
See, I wouldn't have a problem with that. Most of the people wouldn't. Where is it? Why is it not implemented everywhere? That's the boring and low risk AI.
Well, it does still require an infrastructure. In other words, you need to be a digital shop.
Okay.
Right.
But I would argue again, I don't think it's even in every digital shop. Let's be optimistic and say 10% is digital, which I'm just taking out of my head. I don't think it's 10%, but let's say 10% is, I don't think even 10% of this 10% will have those things implemented at the moment.
Well, and then there's, just to go down that road, there's a sort of nice little tributary to all this, which is basically on your microscope digital. So you just have a camera that's sitting up there and you're moving the slide around and it's doing everything you want it to do, right? It's looking at the images, it's counting mitoses, it's stitching together a large field of view for you automatically. You don't have to think about it. You don't change anything about what you do. And you don't have to buy a $200,000 scanner. You don't even need to buy it.
You know what my talk was at the ACP conference, one of the talks? Static telepathology, a thing of the past or a new trend on the rise.
Yeah. So, there are lots of flavors to this, and I'm not sure what's going to win.
Yeah. I don't think we can answer this question. Maybe we should meet next year and have a follow-up conversation. And that's the thing, there's fear. There are the enthusiasts who cannot be naive and are not naive. So they kind of want to promote, but all the concerns are legitimate. So yeah, I guess time will tell. And when there's going to be enough proof that's going to tell the science, the applications, I guess we will just see which way the world goes with this.
Let me hit 2 AI dangers.
Mm-hmm.
One is bad training sets, and I think a sort of classic example of that is breast cancer. I forget which class, but there seems to be different biology of breast cancer for West Africa than for the rest of the world. And the AI tools that are trained in Pittsburgh don't work in, let's say, Ghana. And, how do you monitor that? How do you document that? How do you fix that?
How do you do it? You provide the different data sets, right?
What do you pay for it?
Yeah, how do you pay for it? That's always because there are so many fantastic initiatives and all the questions that they ask, where is it? Where is the smartphone microscopy? Where is the low-hanging fruits? Probably nobody backed it up with enough money to implement it, right? So that there is the answer to my question. But this is also super interesting. This is so recent because I just came from this conference and a colleague of mine, she works for a large pharmaceutical company, and she was asking the same question in the context of diversity, right? And diversity, when you talk about it, it's more let's say in the socioeconomic context, and to be fair and just, but it totally translates into the scientific context and the functionality of the tools. Another example. So I was preparing something for another webinar, and I gave the prompt to DALI, a pathologist at the microscope. Out of 4 images, sadly, 4 of them were white male, right? So yeah, it's all the biases that we have are being translated into the AI development sets. The thing is, some of the biases we know about and many we don't know. I think biologically and through our experience, we are biased creatures. And to undo this bias, we have to be conscious that we are biased creatures and just find the biases. Can you find all the biases? No, right?
They're smarter at generating biases than we are in finding them. Famous classic case of some imaging challenge, and they looked at a bunch of patients from different hospitals, and it turns out that the patient's rooms in one hospital had a blue stripe behind the patient, but it was also a different patient population, and so the AI immediately clued into the blue stripe, and that was their differentiating thing.
Very much, yeah. There was another story like that, with a red dot on a malignant or something. Yeah. Another one that I heard from Anand Madabushi, who was a guest on my podcast. He was differentiating wolves from husky, and it was fantastic performance. And it turned out there was snow behind the huskies always. It leaves us with no answer. Yeah. So what? If you were to express your opinion on AI. What's your opinion? I mean, it's part of your research. On the other hand, you are the author of the paper, What Can Go Wrong? We kind of get to dead ends in the whole discussion, and in parts of the discussion, we reach, there are no answers to the questions. Do you have like an opinion?
Well,
Would you like if you wanted to give an opinion, a short opinion on this? And I'm going to give you mine. Mine is we need to be informed of how these things work. And then that's the best we can do at the moment. But I don't have anything deeper than that, unfortunately.
well, my analogy for AI and pathology, based on something I just read, was automatic bartending robots and what this does to servers serving drinks in a bar.
Uh-huh.
And you think, oh, there are not enough servers, maybe not enough bartenders, we'll just do this. And that means that they can sort of be more efficient, get the drinks faster to the customers, get higher tips. The answer is no, it's the opposite. Why? Sometimes the customer wants a drink with this bourbon or that bourbon, or with or without the lemon or whatever it is, and the bartender robot can't do it. So this poor waitress or waiter has to go running down to find a human bartender to go put the drink together, and he or she may be way overwhelmed. Meantime, the customer gets tired of waiting and leaves. So there goes the whole tip is gone, and she's and the waiter has been running around like crazy trying to make it happen. And so you get all these unintended consequences of something that works 90% of the time, but that fails miserably 10% of the time. What happens then? And I think the short answer is I haven't the faintest idea. We will watch this space, I think, is the best I can do at the moment.
Yeah, good one. Watch the space. And I mean, you have to watch pretty closely at the high cadence as well, because there's going to be like every week there's going to be some revolutionary new perspective or new paper on new technology. To me, it's like, okay, if something doesn't work at the moment, don't make it work. Wait for the next thing to come out. But yeah, a fantastic discussion.
Thank you. It really was.
Thank you so much for joining me. I'm wondering what the listeners are going to say about after this episode. And I love that it meandered like that, and basically, like, it takes us out of the simplistic binary nature of things. Like, I don't know, this was something when I came to the US, it was like, okay, it's pretty binary because there are only like two parties and you either are for something or against. Like, I kind of noticed that it was more than in Europe, and I don't think anything is binary.
It will be fun to watch.
It will be fun to watch. Thank you so much, Richard, for joining me.
All right, thank you.
And I hope you have a wonderful day.
And you too as well. It was a real pleasure.
Thank you.
Right. Bye-bye.
Thank you so much for staying till the end. My favorite thing about this episode was understanding how close we are to glassless pathology. And I would love to understand this topic more. So I'm actually thinking of organizing a more in-depth series or a virtual event or a mini conference about it. So if you're interested in taking part in this, drop me a comment below writing glassless pathology, and I will know that you are interested, and I'm going to start organizing this event. I'm looking forward to hearing from you in the comments, and I talk to you in the next episode.